Today's video will demonstrate how to convert decimal integers into binary integers. Hello, I'm James Helfrich. Most of the integers we use every day are a fixed size. We have 8-bit integers called characters, we have 32-bit integers called ints, we even have 64-bit integers called longs. What if your needs are different? What if you need a 3-bit integer or a 100-bit integer? We need a generic algorithm to be able to work with integers of any size. This video will demonstrate how to convert a decimal integer into a binary integer. Hello, I'm James Helfrich. We all work with integers every day, mostly 8-bit integers called characters or 32-bit integers called ints. Sometimes, though, we need to work with integers of different size. The question is, how do we turn decimal integers into binary integers? In other words, how do we find the binary representation of the numbers we use every day? This video will explain how all that works. We would like to convert a decimal into a binary integer. However, we like to do this with a decimal integer that has an arbitrary number of digits. In other words, we'd like to convert a very large decimal number, represented as an array of decimal digits, into an array of bits. So we'll start with an array of decimal digits. Notice this one has 12 digits, which is larger than a 32-bit integer can handle. And we like to convert this into an array of bits. That's our problem we're trying to solve. So let's demonstrate how this is supposed to work. We'll start with our own custom definition of integer, and we're going to include quote integer.h, and this has our integer class, and it's a template class which is going to allow us to specify the number of bits as a template parameter. Okay, so I'm going to say custom : because I'm going to put it in the custom namespace, integer with a capital I, and then I'm specifying the number of bits. Okay, and I'll call this I. Now, in order for me to add elements into my integer array, I'm going to start with a string stream so I can use the insertion operator. And so I'm going to say std : string stream, and we'll add just a small integer here. How about 42? Because we know 42 is 101010, and it's really easy to see in binary. Okay, so I'm going to send the string stream into my integer using the insertion operator, and then I'm going to set a breakpoint to look at my string stream. Okay, so I'll take a look at my integer, and we're going to see 0, 1, 0, 1, 0, 1, and it works just the way we expect. Okay, so this is my 32-bit integer, and there's 32 bits in my integer bit stream. Okay, I can add an arbitrary number of bits. So let's make something really big here, okay? And when I run this, I also expect to have the same 0, 1, 0, 1, 0, 1, but I'm going to have a whole bunch more zeros after it. And we'll see how many I have there. So now I can make an integer of an arbitrary size. Cool. Okay, now, if I have 10 bits, I can represent 4 digits. If I have 100 bits, I can represent many more digits, right? So in this case, I'm going to represent 30 digits, and 30 digits is about 100 bits. And let's take a look at the implementation here. So I run this, then I'm going to have a whole bunch, and it's going to take 0, 1, 0, 1 all the way down to right about 100 or so. Okay. And that's how our integer conversion is supposed to work. So let's start with our pseudocode. We're going to start with an array of digits called decimal digits, and we're going to convert it to an array of bits called binary digits. And we want to take this array of decimal digits, we have 4 of them, 1, 8, 9, 0, and we like to convert it into an array of binary bits, 1, 1, 1, 0, 1, 1, 0, 0, 0, 1, 0. And both these equal the same value, which is 1890. Let's take a look at how this works. Well, first of all, we're going to loop through all the decimal digits one at a time, and then we're going to create a single binary integer of 4 bits representing a single digit. So 1, and then 8, and then 9, and then 0. Then we're going to take our binary digits and multiply it by 10 to shift it over by a slot, and then we're going to add on our decimal digit, and then we're going to continue the process until we're out of decimal digits. And at the very end, we're going to add our negative as necessary. So let's take a look at how this works. I want to take 1726 and turn it into a binary integer. So I'm going to start with 1726, which is my decimal digits, and my binary digits are going to be all zeros initially. So I'm going to start with my first decimal digit, which will be 1, and I'm going to convert it into a binary digit, which is going to be 0001 binary. And then I'm going to take my right-hand side, which is my binary digits, and I'm going to multiply it by 10. And what this does is basically nothing because 0 times 10 is still 0. And then I'm going to add my binary digit, singular, onto my binary digits, and that's going to give me 1. Now I'm going to go up here and move it to the next element, which is 7, and the binary representation of that is going to be 0, 1, 1, 1. And then I'm going to take my right-hand side and multiply it by 10. 1 times 10 is now going to be 1, 0, 1, 0. And let's make sure that's true. It's 0 plus 2 plus 0 plus 8. 2 plus 8 is 10, so that's correct. And then I'm going to add on my binary digits, which is 7, and that's going to give me 1, 0, 0, 0, 1, which is 17. Now I'm going to move to the next element, which is 2, and the binary representation of that is 0, 0, 1, 0. And then I'm going to take my right-hand side, 17, and multiply it by 10. Now, I can't do binary multiplication in my head, but it's 170. And then I'm going to add on my 0010, which is my binary digit. Then I'm going to move to the next decimal digit, which is 6. And then I'm going to create the binary representation of that, which is 0110. And I'm going to take my right-hand side and multiply it by 10. So 172 multiplied by 10 is something big. Once again, I can't do that binary math in my head. And then I'm going to add my binary digits, and then I'm done. Okay, let's take a look at a second example. We have a 42 in decimal, and I want to turn into a 7-bit and a 9-bit binary. So my decimal is 42, my 7-bit is 7 zeros, and my 9-bit is 9 zeros. And then I'm going to multiply it by 10. And then I'm going to add on the 4, which is 0, 1, 0, 0 to each one. And notice how they're both the same. Then I'll take that one and multiply it by 10. And then I'll take my 2 and add it on. And that gives me 1, 0, 1, 0, 1, 0, both my 7-digit and my 9-digit case. Okay, now I want to find negative 42, so I need to apply 2's complement. Now remember, the first step with 2's complement is we want to invert all the bits, and then we want to add 1. And now we can see the 7-bit and the 9-bit binary representation are a little bit different. Basically, we have more leading 1s in the 9-bit than we have in 7. Okay, let's take a look at another example. We have 51 in decimal, and I'm going to have 2 digits, 5 and 1, and I'm going to initially start with my 10 bits. In this case, is all zeros. So 5, so I multiply it by 10, add 5, which is 0, 1, 0, 1, and that gives me all zeros except 1, 0, 1. And then to go to the 1, I now have to multiply my current value by 10, and then I'm going to add 0, 0, 0, 1 to it. And that's my final answer. So let's just check that we have right here. So 5, 1 in decimal is 0, 0, 0, 0, 1, 1, 0, 0, 1, 1 in binary. Okay, let's take a look at 103 in decimal. And let's convert it to 10-bit binary. So I have 1, 0, 3, 3 decimal digits. So 1 is going to be multiply that by 10, add on 1, we're good to go. And then 0. Now I'm going to take that 0, 0, 0, 0, 1, multiply it by 10, which can be 0, 0, 0, 1, 0, 1, 0. And then I'm going to add my 0. And then I have my 3. So I'll take that 10, multiply it by 10, and that'll be 100. So 1, 1, 0, 0, 1, 0, 0. And then I'm going to add on my 3. And that's my final answer. So 103 in decimal is the same as 0, 0, 0, 1, 1, 0, 0, 1, 1, 1 in binary. To learn more about working with integers, especially converting decimal integers into binary integers, take a look at the integer chapter in the C++ data structures textbook.